Welcome to my channel Ravikumar Academy. This is a lecture series on single variable calculus. In this lecture, we are going to learn some applications of Lagrange's mean value theorem. We are going to solve some problems related to Lagrange's mean value theorem applications. So what is Lagrange's mean value theorem? The statement is if f is a function such that f is continuous on AB, closed interval AB, and f is differentiable in open interval AB, then there exists at least one C belonging to the open interval AB such that f dash C is equal to fb minus fa by b minus a. So satisfying this condition, you can find a C, right, that can satisfy this condition. So that is what the essence of Lagrange's mean value theorem. Now we are going to apply this. That means, so how do you apply? When any given function f satisfies these two conditions, then we can use this conclusion. We'll use this conclusion to prove something, right? That is what application of Lagrange's mean value theorem. Now let us take this problem. This is very important problem in the examination point of view. If 0 less than a less than b less than 1, that means 0, a, b, 1. So a and b lie in between 0 and 1. So in this interval we are going to work. So we need to find that particular c in between a and b, right? So that is very important here. So here what we have to do is we have to prove this b minus a by square root of 1 minus a square less than sin inverse b minus sin inverse a less than b minus a by square root of 1 minus b square, and hence deduce that. That means we have to deduce this inequality from the given, or we need to prove this. From this proved inequality, we need to deduce this inequality. Okay. So this is an application of Lagrange. When the moment you see this problem, you should realize that application of Lagrange's mean value theorem. So here what we have to do is we have to take the function. First of all, we should predict what could be the function. Whenever you are given sin inverse b minus sin inverse a like this, you remember you need to take the function f of x as sin inverse x in the interval a comma b, closed interval a comma b. So consider like this, right? So then we know what is f dash x, the derivative of sin inverse x, 1 by square root of 1 minus x square, right? And x is belonging to ab, and how are a and b? 0 less than, a less than, b less than 1. That means a and b cannot be 0 and 1. That means a and b cannot be 1 particularly, less than 1. So when the denominator is going to become 0, when 1 minus x square becomes 0. That means x square equal to 1, x equal to plus or minus 1. So anyway, plus 1 is not there, minus 1 is not there here. So x is equal to 1 we need to test, but b is less than 1. So whatever x you take in between a and b, that cannot be 1, right? Therefore, this function f dash has no problem in this domain. So therefore, f is differentiable. F dash exists means f is differentiable in closed interval AB, in fact. So differentiability implies continuity. That means f is continuous in closed interval AB. So the first two conditions of Lagrange's mean value theorem satisfied for this particular function. Therefore, we can use the conclusion that we can find a C in between A and B that satisfies this equation, right? So We make use of this Lagrange's theorem and conclude that therefore there must exist a C, at least one C, in between A and B open interval such that f dash C is equal to fb minus fa by b minus a. Right. So here what is f dash C? F dash C is 1 by square root of 1 minus C square. This is f dash C. This is equal to fb minus fa by b minus a. So wherever you have 1 by square root of 1 minus c square, you can replace that by this quantity. Right. Now, all these type of problems should be started with this thing. C belonging to AB open interval. That means what? A less than C less than 1. C is in between A and B. Right. So from this, what we have to do is, here we should bring f dash C in between this and this, these two inequalities. What is f dash C? F dash C is 1 by square root of 1 minus C square. So we should bring 1 by square root of 1 minus C square between these two inequalities. So for that, what should we do? We have to square the C, first of all, to get C square. And then you multiply it by minus 1. And then you add it 1. And then you take square root. And then you take reciprocal. You take the reciprocal, you will get this one. Okay. So that is the order. It is a square less than c square less than b square. So whenever you square something, the inequality won't reverse. We have only two particular cases in which the inequality get reversed. When you multiply the entire inequality by minus 1, a negative quantity, the less than will become greater than will become less than. Okay. And the other thing is, when you take the reciprocal b by a, when you consider the reciprocal of the entire inequality, then less than will become greater than and greater than will become less than. That means the inequality gets reversed. So here we have got c square in the middle. We need to get minus c square, negative c square. You multiply the entire inequality by negative 1. What happens? The less than will become greater than. Right? Inequality gets reversed. Now we need to get 1 minus c square. Adding 1, you will get greater than 1 minus c square greater than 1 minus b square. That means we have added 1, nothing will change. That means the inequality won't change. Now you consider the square root of this, square root of 1 minus a square greater than square root of 1 minus c square greater than square root of 1 minus b square. Because taking the square root doesn't change the inequality. Okay? So that is what we have got here, greater than. Now you take the reciprocal. Why should we take the reciprocal? Because you have 1 by 1 minus 1 by square root of 1 minus c square here. So you should get it in the middle. So you take this reciprocal, you will get 1 by square root of 1 minus a square less than. Whenever you take the reciprocal, the inequality gets reversed. Therefore, it is greater than will become less than. 1 by square root of 1 minus c square less than 1 by square root of 1 minus b square. Now we have got 1 by square root of 1 minus c square in the middle, right? So you name this one by equation 1. So you can replace 1 by 1 square root of 1 minus c square by right hand side quantity, right? So you can write here fb minus fa by b minus a less than 1 by square root of 1 minus b square. So by equation 1, right? Now you multiply everything by b minus a, because we are given a less than b, that means b greater than a, both are same. and b minus a is the positive quantity. Positive quantity. Well, because b minus a is positive, even though you multiply everything by b minus a, the inequality won't change. Still it remains as less than. So the middle term becomes fb minus fa because b minus a gets cancelled when you multiply everything by b minus a. So here also you'll get b minus a by square root of 1 minus b square. And what is f of b? B minus a by square root of 1 minus a square less than what is f of b? F of b is sin inverse b. F of a is sin inverse a less than b minus a by square root of 1 minus b square. So this is what we are asked to prove. The first one we have proved just now. And hence deduce that this thing we have to derive from this inequality. So what is there here? Here you have sin inverse b minus sin inverse a, right? And here you have sin inverse 3 by 5. So here you have pi by 6, right? In place of b you have 3 by 5. Okay. So in place of b you take 3 by 5. In place of a, what to take in place of a to get pi by 6? We'll predict that, right? So in place of sin inverse A, we should get pi by 6. That means A equal to sin pi by 6. Sin pi by 6 is sin 30 is half. Right? Therefore, put A equal to half and B equal to 3 by 5 in equation 2. In equation 2. So which is equation 2? This one is, you name it as equation 2. Then what will happen? It is b minus a is 3 by 5 minus 1 by 2 by square root of 1 minus a square. A square is 1 by 2 whole square. Less than sin inverse b minus sin inverse a. A is 1 by 2 less than b minus a 3 by 5 minus 1 by 2 by square root of 1 minus b square. 1 minus b is 3 by 5 whole square. So when you simplify this, you will get the answer. Numerator, it is 6 minus 5, 1. Numerator is 6 minus 5, 1 by 10. In the denominator, it is 1 minus 1 by 4, it is 3 by 4 less than sin inverse 3 by 5 minus sin inverse half is 5 by 6 less than, again this is 1 by 10 by square root of 1 minus 9 by 25. So this is 1 by 10 into, you can write root 3 by 4 as 2 by root 3. When it comes to the numerator, it becomes 2 by root 3 because root 4 is 2. And this is sin inverse 3 by 5 minus 5 by 6 less than 1 by 10 multiplied by, this is 25 minus 10, 16. 16 by 25. Under root 16 by 25 is 4 by 5. So when it comes to numerator, it becomes 5 by 4. So this 5 cancelled for 2 times. Here this 2 cancelled here 10, 5 times. So 1 by 5 root 3 less than sin inverse 3 by 5 less than minus 5 by 6 less than 1 by 8. Now we add pi by 6 throughout the inequality. Throughout the inequality, you will get pi by 6 plus 1 by 5 root 3 less than sine inverse 3 by 5 less than 5 by 6 plus 1 by 8. 5 by 6 plus, we have 1 by 8 here. So hence deduced. So this is very important problem in the examination point of view. We are going to solve some more similar kind of problems in the next videos. Thank you so much. Please subscribe to my channel if you have not subscribed yet. Also like this video, share it with your friends and classmates. Comment your feedback. Thank you so much.